Hello again, my name is Magnus Holberg, and maybe you have seen some of my other videos in the beautiful field of water treatment. If this is your first one, well, just hang in there. Today I'm gonna talk about treatment of tunnel water, or from drill to dust in the water. Now I'm gonna show you one picture, and you see that picture, you will find a very dirty water coming out from the pipe. This water is coming up from a tunnel front down in the rock where the tunneling is done. So actually it's all the way up front where they're blasting and drilling away in the rock. Now, how do you treat this water? Can you treat this water? Yes, of course you can treat water. You can treat every kind of water. It's just a case of what methods you're going to use. So how did this water look after treatment? Well, it looked like this. And going out to the recipient, it was pumped out. You had a suspended solids concentration of less than 5 milligrams per liter. Now, before I continue, just a short note on suspended solids or particulate material. From the tunnel front, you can have concentrations well above 5,000 milligrams per liter. Compare that with raw sewage water, where you might have somewhere in the range of 200 to 350 milligrams per liter. And the treated water in this case is quite close to drinking water. The TSS is not measurable, so as you see also in the picture is very clear water. But now let's look at the pollutants and how to treat them. So, what are the main pollutants you can find in processed water from tunneling? Well, let's have a look at the first one, pH. And the pH is from having to work with concrete down in the tunnel. We have suspended solids, or TSS, total suspended solids, which is basically particulate material that is drilling mud and, well, other small particles, but to 99% it's rock that has been drilled out and excavated. Then we have oil. Well, not so much, but maybe some small hydraulic leakages and so forth and so on, but usually in very low concentrations. And also you have nitrogen compounds from blasting. So these are the main, how should I say, pollutants you can find: pH, TSS, oil, and nitrogen compounds. So let's continue and see what's on the next slide. So let's look at the first one, pH, and how to control it. Well, what you see in these waters, you have variations in pH. And as I said, it's when you use concrete, when you have very high pH in the tunnel or the processed water. And these pH can go above 12, so you have a very alkaline water. Now the question is, how do you neutralize or reduce the pH when you are using concrete and you get these very high pH in the processed water? Well, as in any other water treatment situation, you neutralize it with acid. And on the top hand side picture, you have the container with the two green pumps. That is sulfuric acid. And this is from one project I worked on. And sulfuric acid is a very aggressive chemical, but it's a standard chemical, and treated correctly, handled correctly with safety and all of that, it's an excellent source for neutralization of the tunneling process water. Also, if you don't want to use a mineral acid, you can use carbon dioxide, which also is an acid, of course. With carbon dioxide, you have to look at the introduction system to the processed water. But you can use either one, but you have to be sure that you dose it and control the dosing pumps correctly. But standard issue, standard procedure. So pH control, use acid. So how can it look when you are controlling the pH in a processed water? Well, that will come on the next slide, of course. So, how does pH variations show up in real rough raw tunneling. I try to make it a little more exciting by having a nice headline. But let's be serious, let's look at the graph. Here you have on the x-axis, you have the date. And as you can see, it's some years ago, but believe me, it won't change. Acid, concrete, processed water, this is how it looks. So x-axis, you have the time frame. On the y-axis, you have pH from 0 to 14. As you can see here, the blue staples are the incoming water, or should I say upcoming water from the tunnel. And here you can also see the variations between maybe somewhere just close to 8 up to, well, above 12, as I said before. And you can see the green, that is after neutralization. In this case, we used carbon dioxide. So you can see it's a very good controlled process that we had in this project. As you can see, it's almost, well, not almost a straight line, but the set value was 7, and we actually did a hell of a good work. Sorry, I shouldn't swear on YouTube. We did a very good work on making this pH control. So let's go on to the next pollutant, which will be, well, maybe you can guess, suspended solids, but that will be on the next slide. So, suspended solids removal. In order to do this, if you remember the picture on the first slide, you have a very, very extremely high load of suspended solids. In order to remove it, to have a very high quality water or a very clean water coming out, low on suspended solids, you need to take it in steps. The first steps, when it comes up from a tunnel, you need a pre-sedimentation. And here you see a dam, which is a dug dam, but you can have container solution, all depending on what flow you get up from the tunnel. But after pre-sedimentation, you usually have a suspended solids concentration below 500 milligrams. So this is like a coarse separation. Then, for the next step, you use flocculation and sedimentation. You can see the picture here of some tests we did many years ago. Again, you can do them today again, where we tested different flocculants. But basically, flocculation in order to enhance the very, very fine particles that you will have from a drilling mud. So you get larger particles so you can have decent sedimentation times. So flocculation, sedimentation, and then finally sand filtration. And after flocculation and sedimentation, you will be running down below 100 milligrams per liter. After the sand filtration, below 25 milligrams per liter. Now, how does the flocculation and sand filtration step look? On the picture here, you see, I don't think it's me because I took the picture, but on top of the vessel that the guy is standing, that is a continuous sand filter. Beside that, you have a lamella sedimentation or separation unit. And you see in the lamella separation unit, you see a tank, which you see on the arrow here, which is the flocculation tank. After that, you have the sedimentation vessel. And after the sedimentation vessel, it will be sent to the sand filter. So that's how you make this treatment process work. Pre-sedimentation, flocculation, sedimentation, and sand filtration. What steps you need is, of course, dependent on the demands you have on the water you send to the recipient, or you send it to the sewage network, or wherever you want to send it. So, suspended solids. What's next? Well, wait and see. It's soon coming up. Let's go to the next slide. So, we come to oil and nitrogen compounds. Now I'm going to disappoint you. Well, maybe not. Maybe you didn't like the video, so you haven't even come this far, or you maybe leave the video now. But after an access view of 250, I will give you a video on how to handle oils and nitrogen compounds from tunnel process water. So, if 250 views, can be negative or positive clicks, I don't care, but 250, then I know there is an interest. then I will post a video on how to get rid of the oils, where you can handle them, and also the tricky one, nitrogen compounds. So 250 views, my friend, or should I say 251 views, you will make me make another video, which I probably enjoy quite a lot. So with that said, I will just say, not thank you yet, but I will show you a picture from the town I live, called Visby, in the island of Gotland. And this is a picture I took during the medieval week. And if you want to go to a very nice place in the summer, I could also say wintertime, but not so many would agree with me, but it's a beautiful island. And in the summertime, we have so many things going on in the island, and this is just from one of the events. I think it's 1 week, they have a medieval week. And so just a little bit of a commercial for where I live, but very, very nice medieval happening, I should say. With that, no more commercials. I will stop and I will say thank you, and don't forget, water really rocks. Take good care, and hope I can post that video soon about oil and nitrogen. Take care. Bye-bye.